Sound is everywhere. It's the music you hear, the words you speak, and even the noise your shoes make on the floor. We use sound every day to talk, listen, and understand the world around us. When you clap, tap, or sing, you're actually creating sound waves that travel through the air. Sound helps us connect with people, and honestly, it helps us learn new things too. Sound travels in waves. These waves move through air, water, and even solid things like metal or wood. That's why you can hear someone talking in another room if the door is open. Sounds can be loud, soft, high, or low, and each sound tells us something special about the world. But have you ever wondered what sound really is? Why does it travel through walls but not through space? Scientists ask these questions all the time. The more we learn about sound, the more amazing it becomes. Sound is not just for fun, it's also very useful. We use sound for music, communication, and even to help doctors check our hearts. So let's dive deeper and discover the secret particles behind every sound you hear. Every sound you hear is made up of tiny moving parts. When something shakes, it makes the air around it vibrate. These vibrations move in waves, and that's what your ears pick up as sound. But scientists have found that there's something even smaller making these waves happen. Inside things like crystals or metals, sound travels as tiny particles called phonons. Phonons are like little packets of sound energy. They're not particles like dust or sand, but they act like particles when sound moves through solids. You could say phonons are the building blocks of sound in the same way that photons are the building blocks of light. When you tap a spoon on a table, you create a lot of phonons zooming through the table. In fact, phonons are what carry the sound from your tap to your ears. They're invisible, but they're always moving and bumping into each other inside solid things. Phonons are a new way to think about sound. Scientists study phonons to understand how heat and sound move through things. Now, they're learning how to control these phonons in amazing new ways. For a long time, people have used light and electricity to send messages. Computers, phones, and the internet use tiny flashes of light or electric signals. These signals move very fast, sometimes even at the speed of light. Fiber optic cables, for example, use light to carry internet all over the world. But light and electricity have limits. Light cannot go everywhere. It cannot go through thick walls or deep underground. Sometimes, electric signals get weak or lost in certain places. This is why scientists are always looking for new ways to send information. Sound is different. It can travel through solids, liquids, and gases. In some situations, sound can go where light cannot. For example, you can hear a knock through a wall, but you cannot see through the wall. This makes sound a powerful tool for communication, especially in tricky places. Could we use sound, or even tiny phonons, to send messages in new ways? Scientists think so. They are working on new devices to make this possible. Imagine trying to send a message deep inside a mountain or through thick metal. Light would get blocked, and electric signals might not make it. But sound can travel through these tough places. That's because sound waves move by shaking atoms in the material. This makes sound special. It's sometimes the only way to send signals in places where light or electricity cannot go. Submarines, for example, use sound to talk underwater, since light doesn't travel far in water. Even animals use sound to communicate in places that are dark or full of obstacles. Scientists wondered, could we control sound at the tiniest level, using phonons to send messages in new ways? If we could, it would open up a whole new world of technology. It might even let us build computers or sensors that work deep underground, underwater, or in space. That's why learning to control phonons is such a big deal. If we master them, we can send information through places where nothing else works. Now here is the exciting part. Scientists at McGill University have invented a new device. This device can make and control phonons, those tiny particles of sound, like never before. How did they do it? It's a mix of cool science and clever engineering. First, they use a super thin crystal, only a few atoms thick. This crystal acts like a tiny highway for phonons to travel. Then they make it very, very cold, almost as cold as outer space. This stops other particles from moving around and messing things up. The next step is using electrons to create phonons. When the scientists send electricity through the crystal, the electrons jump around. As they move, they kick atoms in the crystal, making them vibrate. This creates phonons, which start zipping through the material. By controlling where and how the electrons move, the scientists can decide exactly when and where to make phonons. It's like pressing keys on a piano to play notes, except the notes are tiny packets of sound. Why does the device have to be so cold? Well, at room temperature, atoms jiggle and bounce all over the place. This creates noise, which makes it hard to control tiny phonons. By cooling the crystal to almost absolute zero, the atoms slow down. The phonons can move in a smooth, controlled way. Absolute zero is the coldest anything can get. It's minus 273.15 degrees Celsius, or minus 459.67 degrees Fahrenheit. At this temperature, almost nothing moves. By reaching temperatures close to this, the scientists can make sure only the phonons they create are moving through the crystal. With this control, they can send, stop, and even catch phonons. This is a big breakthrough. It means that for the first time we can use sound as a tool for sending signals in ways that were never possible before. This kind of control opens up many new possibilities for technology. It is a step forward in what scientists call quantum sound. What can we do with this new control over phonons? The possibilities are honestly pretty exciting. One big idea is using quantum sound devices for super fast communication. Because phonons can travel where light cannot, we might build new kinds of computers or phones that work in places with no light or radio waves. Doctors could use this technology too. Imagine medical tools that use sound to see inside your body, even better than today's ultrasound. These tools could find problems sooner and help people get better faster. Sensors using phonons could also spot tiny changes in buildings or bridges, keeping us safer. Phonons could even help us build better quantum computers. These are special computers that use the strange rules of quantum physics. Quantum computers are very fast and can solve problems regular computers cannot. If we use phonons to move information between parts of a quantum computer, we could make these machines work better and faster. From communication to medicine to safety, quantum sound could change the way we live. It is a brand new way to send information right under our noses. Did you know that you can hear a crystal ring just like a bell? When phonons move through a crystal, they can make it vibrate at special pitches. Some scientists even call this the music of the crystal. Phonons move much slower than light, but they can still go very fast, thousands of meters per second in some materials. That's faster than a jet plane. Atoms are so small and phonons are even smaller. A single crystal chip could hold trillions of phonons at once. That's like filling a stadium with tiny sound particles all moving in perfect harmony. Isn't it amazing how something we cannot see or touch can help us build the future? Next time you hear a sound, remember, you might be listening to trillions of tiny phonons at work. Science is all about asking questions and discovering new things. The invention of the quantum sound device is just the beginning. It shows us that even something as simple as sound still has mysteries waiting to be solved. With this new technology, we can dream of phones that work deep underground, medical tools that see inside our bodies better than ever, and sensors that keep us safe. Maybe one day, we'll even build computers that talk with sound, not just light or electricity. The future of sound science is bright and full of surprises. Who knows what we will discover next? Keep listening, keep asking questions, and remember, science rules.